Hey, Fourth Year, and welcome to this fertilisers revision video. This is going to take us through all the knowledge that we need to know for the fertilisers topic. The fertilisers topic isn't that big, so it's not going to take that long to go over it. Okay, but let's get into it. So, the basics of fertilisers is that growing plants requires nutrients, and the main nutrients that plants require to grow healthily is nitrogen, potassium, and phosphorus, the NPK elements. Okay. Fertilizers are substances which restore elements to the soil, and there's two main compounds that can be used in the production of fertilizers. That's ammonia and nitric acid. They're mostly used because they produce soluble nitrogen-containing salts. Okay, remember the two things that are needed for a good fertilizer is one, it needs to have the NPK elements, or at least one of them, and two, it needs to be soluble in water in order for the roots of the plant to, I'm going to say suck it up, but absorb. That's the word I'm looking for. Okay. So ammonia, pungent, clear, colorless gas, which dissolves in water to produce an alkali. Ammonia solutions react with acids to form soluble salts. So ammonia, while it can dissolve into water to form an alkali, it can also act as a base on its own. So ammonia solution plus acid would give ammonium salt plus water. So for example, ammonia solution plus nitric acid would give ammonium nitrate, because nitric acid forms a nitrate salt, plus water. Okay. We can make ammonia using the Haber process. So this is the equation that you need to know for the Haber process. Fair warning, there has never been a question asking you to remember that equation. However, it is in the course spec, so they very well could ask it. Okay, so it's not that hard an equation. It might just be a good idea to memorize it. So you've got nitrogen, N2, plus 3 hydrogen molecules reacting together to give NH3 plus. Remember this symbol is the equilibrium symbol. That essentially means that the reaction can go forward and backwards. So nitrogen plus hydrogen will react to give nitrogen ammonia, but also at the same time, ammonia can break down back into nitrogen and hydrogen. Okay, and this happens at the same time. So we need to find a way to ensure that the majority of the reactions are the forward reaction and that we minimize the backwards reaction as much as possible. We can do that by increasing the temperature. Okay, so at low temperatures, the forward reaction is just too slow. Okay, if the temperature is increased, the rate increases, but the reverse reaction becomes more dominant, so there's a balancing act. You can't increase it too much because then the backwards reaction takes precedent over the forward, but you want to increase it a bit so that it becomes fast enough. Okay. The way we can overcome that is by using an iron catalyst. Okay. So remember, Haber process uses an iron catalyst to make ammonia. The second compound that we need to know how to make is nitric acid. So not a lot you need to know for this. You need to know the Ostwald process and try and remember how to spell that. There is debate whether spelling of Ostwald matters because it's a proper noun. Normally you would say spelling doesn't matter, but for names it does. So try and remember it's Ostwald. I say Ostwald all the time. It's Ostwald. That uses ammonia, oxygen, and water to produce nitric acid. Okay, you need to remember ammonia, oxygen, water produces nitric acid. And instead, in this case, it's a platinum catalyst used in this process. The way to remember it is Hippo. So Haber uses iron. Platinum is for Ostwald. Okay, if you remember that, then you'll be able to answer the majority of questions based on fertilizers. And that is everything you need to know for fertilizers. Really short topic. I imagine that you'll be able to go on and do one of the other tasks from today based on another topic. Okay, But carry on with the work and see where you end up. Okay. See you later. Thanks, guys.